For section 2.3, our goal is to be able to solve proportions and identify when shapes are similar. Our first example, we are given a proportion. To solve a proportion, we cross multiply. So what would happen is we would have 12 being multiplied by A, and then we'd set it equal to 7 being multiplied by 24. Now, some of you will skip that step and you'll go straight to saying that there are 12 A's equal to 7 times 24 is 168. And then in order to solve it, we want A by itself, so we would divide by 12. That cancels out. A equals 168 divided by 12 is a 14. Example 2, we're going to cross multiply. I think I've heard some call it like a butterfly as well. So that would be a negative x times a 21 equal to a 7 times an 18. The order you write these in doesn't matter. Just make sure that they're grouped with the cross sections. So that would end up giving me negative 21x equal to 7 times 18. And then I would divide by negative 21. 126 divided by negative 21, x equals a negative 6. Example 3, I cross multiply. So I would have go up here, 6 times b plus 2, and then I'd have a 3 times a 5. So then when I simplify that, if you skip this step, you'd end up having 6b plus 6 times 2 makes a 12. 3 times 5 is 15. To solve, we would subtract the 12. 6b equals, that would leave us with a 3. And then we would divide by the 6. So b would equal 1/2, or you could say that it equals 0.5. Both would be correct. And if you're checking your work, 15 minus 12 is 3. Then we divide by 6, 0.5. Okay, on example 4, we cross multiply. So I would have the 4 being multiplied by b plus 3 equal to the 3 times the 20. 4b, 4 times 3 makes a 12. 3 times 20 makes 60. We would then subtract the 12. 4b's alone equals 48. I'm going to double check my work. So 60, take away the 12 is the 48. And then we divide by the 4, which would give us a 12. 48 divided by 4 is a 12. Example 5, we cross multiply. I'll bring it over here so I have more room. I have 2 being multiplied by 3x minus 57. And then I have a 6 being multiplied by negative 2x minus 4. So this is the most difficult one that you could get with a proportion. Okay, so I have it set up. I'm now going to multiply 2 times 3, 6x. 2 times negative 57, negative 114. 6 times negative 2, negative 12x. 6 times negative 4, whoops, negative 24. I now want to solve for x. There are 2 x's here. I cannot just like combine them together, so I need to move them across this equal sign. So we're going to add 12x. Add 12x. 6, 7, 8. That gives us 18 x's. Minus 114 equals negative 24. Add the 114. 18x equals negative 24 plus 114 is 90. Divide the 18 off. 90 divided by 18. X is equal to 5. So that is how we solve proportions. Our next examples want us to provide an argument to prove each conjecture or provide a counterexample to disprove it. So example 6 states that all right triangles are similar. Well, I can disprove that because I can have a right triangle with 45 degrees and 45 degrees, which is an isosceles triangle. Or I can have a right triangle that is a 30, 60, 90 degree triangle. And in order for a triangle to be similar, a right triangle to be similar, they need to have their angles should be equal and their sides should be proportional. So this proves that not all right triangles are similar. Example 7, the polygons on the grid are similar. So when I compare, let's look, M to N, this is our pre-image, is 2, and this is 1. So it looks like it went from 2 to 1. On my next side, I'm looking at the slope of this line, 1 by 2, 1 by 1.5. Now I'm going to look at the top, 2 by 1, 2, 3, 1.5 by 1, 2, 3. The next side is 2 by 1, 2, 3, 1 by 2. So these images, based off of their slopes, the side lengths were not changed by the same amount. So this would be called not similar. We're gonna check B. Okay, we are given, it looks like they're a little twisted. So I'm gonna look at I to J. It's 3. I to J is right here. It's 1.5. So it looks like it was cut in half. So let's see if all the other ones were cut in half. J to K is 2 by 2. So J to K, 1 by 1. That makes sense. 2 and 2 to 1 and 1, that was half of it. K to G is 2 by 2, 1 by 1. 2 to 2 went to 1 to 1. That's good. That's proportional. And 1, 2, 3, 4. 2, 3. So it went from 4 to 3. So that means that 4 should be 2. And then 3 should go to 1.5. Yep. So these are similar because our pre-image was just cut in half in size, or dilated. It was dilated by half. Example 8. A sequence of transformations occurred to create the two similar polygons. Provide a specific set of steps that can be used to create the image from the pre-image with 1, 2, or 3 transformations. So I'm going to use a little clear sheet. Here is my pre-image. And my goal is to move it onto the image. Whoops. So first, I'm going to start by rotating it. As I rotate it, it ends up being right there. So I'm going to say, first step, rotation. Then in order for it to be here, I'm going to just do like a flip, which flips it right on top. That is called a reflection. So we did a rotation and then reflected it. All right, question B. Here is my pre-image. I'm going to move it so that it lines up with the other one. Let's see. M, I, K. Let's see if that helps. It's a little messy, but okay, our goal is to match it onto its image. So if M is there, K and I, okay, it looks like K and I are flipped. So I'm going to do a reflection, which will flip the I and the K so that they're now on opposite sides. Then I'm going to rotate it and then translate it over. And that maps it onto its image. Okay, example 9. One definition of similar triangles is based on transformations. However, there are other criteria for determining whether or not triangles are similar. What are these other criteria? So we can say that triangles are similar by angle, angle, similarity. That means that if they have two matching angles, then the other one will also match. We can say angle, side, angle, side, angle, side. All three sides. HL is kind of weird. It's the hypotenuse and the leg, so it would need to be a right triangle with the hypotenuse and a leg and the 90-degree marks. You'd have to have the 90-degree in the corner for hypotenuse and leg. And then we have angle, angle, side. So when we check example 10, we are given that these angles match and these ones match. Similar by angle, angle. And we don't have to prove anything because the angles are matching. On B, they've given us sides and we have these vertical angles. So they're not marked, but we know that those are matching. Okay, so those are vertical angles, those angles match. We are going to check our sides to see if they're proportional. So I'm gonna start with the small side. I'm gonna put 121 over the large side. Same thing here, small side over the large side. You have to make sure you go with the same pattern. So when I check it, 121 divided by 132, 9.1666, 33 divided by 36. If these match, right, the proportions, they are proportional. So I would have that they are similar by side. Here's an angle, and here's a side. Then we fill in triangle RQP. Triangle RQ is the large side, to P is the blank, so it goes along the large blank. So I would say triangle R, the large side is 36, so it'd be C, then to the blank, D. Example C, we have three sides, so I'm gonna check them. I'm gonna start with the small side, 42, the middle side, 77, the large side is 92. Small side on my bottom triangle is 3, the middle, 55, and the largest size is 65. I'm gonna see if they are proportional. 42 divided by 30, 77 divided by 55, 92 divided by 65, 92 divided by 65. This one threw it off. So 1.4, 1.4, they were matching so far, but as soon as we got to the 92 over 65, the sides are no longer proportional. So, because that one threw it off, not similar.
Good morning, everyone. Happy Monday.
Because they are not similar, and this one, that proportion messed up the similarity, we do not have to fill in the similarity statement. If they had all matched, they would have been similar by side, 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 because you are given 3 sides and no angles. D. We have 70 and 70. So we have matching angles, so there's an angle. And we have our sides. We have 80 as our smallest, and then 88. On here, our smallest is 30, and then our largest is 33. So I'm gonna check if they're proportional. 80 divided by 30. Okay, 88 divided by 33. Our decimals match, so these are proportional. They're the same, they're similar size. So that means I have a side, I have this angle, and then I have this side. And on here, it's the same thing. Side, angles in the middle, side. So watch the order that they are on your triangle, and that should help you fill in the similarity. D, E, F, D, E goes along 88, then to F. So if I start on D, it should go along the 33 first, then along the blank side. So it'd be D, L, M. Example 11, for each pair of similar polygons, give 3 ratios that would be equivalent. If possible, find the missing sides. So I have my triangles. I'm going to solve for x. So in order to solve for x, I need to set up a proportion. To set up the proportion, I needed to know the side lengths. So this is long, this one's short. This one is short, and this side is the long side. So when I set up my fractions, you have to make sure that you set up the same pattern. So if I do the short side over the long side, then it should be equal to the short side over the long side. So you have to use the same pattern. Short over long, short over long. If I did long over long, I would then do the short over the short. Follow your pattern that you set. We then can cross multiply. So that would give me 48 times 2x minus 15. And then I would have 78 multiplied by 8. Then I'm going to solve for x. So then that would give me 48 times 2, 96x. 48 times negative 15 is negative 720. 78 times 8, 624. Add the 720. 96x equals 624 plus 720, 1,344. Divide by 96. Divide by 96. X is equal to 14. Be careful if the question on your assignment asks you to find what S to L equals. you would have to go from S to L, which is 2x minus 15. Plug the 14 in. So you would do 2 times 14 minus 15, which gives you that missing side length. This length is a 13 right here. So be careful if they're asking for x or if they want you to find a side. Solve for x, find a side. So just be careful for what they're asking for. Example B. I am given that this angle is 50. This angle is 50. And then they told me that I have a 26 here and a 26 there. This is 65, so then this, if they're similar, which they tell me they're similar, if this is 26, 26, then 65, this should be 65. So I know that if they ask me to find the side, B to C, is 65. If they ask me to solve for x, then I could say that 15x plus 5 should equal 65. I don't have to set up a proportion because I know they should be equal from the start. Then we would minus the 5 and then we would divide by 15. Divide by 15 is 4. So you can solve for x and you have the ability to find the missing side. All right, question C. We're gonna set up a proportion. So I'm given side lengths, side length, side length, side length. I'm not given a base of the triangle. If you're ever given a base of a triangle, you have to be really careful. So right now, because we have just the sides, I'm going to set up a proportion. And I'm going to kind of leave it the way it looks in the triangle. -3 plus 10x over 45. So I did top over bottom, so I would do 27 over 45. Then we're going to cross multiply. So when I cross multiply, that's going to give me 45 times -3 plus 10x equal to 45 times 27. (45 times -3, -135. 45 times 10, positive 450 with an x on it, equals 45 times 27, whoops, I was wrong, 1,215. We are then going to try and get the 135 over with the 1,215 because they are like terms. We want to leave the x by itself. Plus 135, 450x equals 1,350. Then we divide by 450. 1350 divided by 450 is a 3. Solve for x. Now let's see if they have any missing sides, if they could want them. D to G is 45, F to C is 45, B to E is 27, B to G, if I plug it in, -3 plus 10 times the x was 3, is 27. So if you found a shortcut and you notice that 45, 45, 27, 27 and set them equal like up here, completely fine. There are a lot of ways you can solve for x and solve for missing sides.